Hi guys, we're back with Newton's first laws. Please have your science notebook out. We are going to talk some more about Newton's laws, specifically the second law today. Newton's second law is, I'm sorry, copy the notes down in your notebook as we go along. Newton's second law is designated by the equation F equals m times A, or force equals mass times acceleration. So the second law states the net force acting on an object is equal to a product of its mass and acceleration, or F equals ma. When his mass is in kilograms and acceleration it is in meters per second squared, the unit of force is measured in newtons. So 1 Newton is equal to the force required to accelerate 1 kilogram of mass at 1 meter per second, and it's second squared. So that's why you see 2 seconds. It's not a mistake. All right. So the second law says force, remember, equals mass times acceleration. So how much force is needed to accelerate a 1,400 kilogram car 2 meters per second squared? So you write the formula first, F equals m times A, and fill in the given numbers and units. So F equals 1,400 kilograms times 2 meters per second. And then solve for the unknown. So basically 1,400 times 2 equals 2,800 kilograms per meter second, or 2,800 newtons. If mass remains constant, doubling the acceleration doubles the force. So if force remains constant, doubling the mass halves the acceleration. So here, where your mass is constant, if you double your acceleration, you get an increase in force. If the force remains constant right here, and you doubling your mass halves the acceleration. So if you go, let me go back. If you go from 2 down to 1, you get this in half. Newton's second law proves that different masses accelerate to Earth at the same rate, but with different forces. So we know that objects with different masses accelerate to the ground at the same rate. However, because of the second law, we know they don't hit the ground with the same force. So if you look, this big rock and this small rock are both accelerating at the same rate because the rate pulling them down is gravity. However, this rock is 10 kilograms of mass, where the other rock is only 1 kilogram of mass. That makes our numbers different. So the force is different. This is the famous, I went too far. So this is where he was sitting under the apple tree and force pulled the apple on his head. Okay. So let's check our understanding. So what acceleration will result in a 12 net force being applied to a 3 kilogram object or a 6 kilogram object? So you are using what? Shh. Yes, I am. Okay, so we're going to work through these, and I want to skip these now because we're going to work through them a little bit differently. Okay. So a force is a push or pull, remember, that causes an object in motion. And we have lots of different forces that can act on our object, and we're going to use them to calculate acceleration next. All right, once you have this, you are then going to go to the next document, Newton's second law, the law of acceleration. You're going to open that with Cami, and you are going to complete the worksheet. All right, please have the worksheet done by the time it's time for us to meet, because then we will go over the worksheet and Newton's second law.